We're now going to look at some other large-scale atmospheric circulations, but these ones don't quite fit with our three-cell model of atmospheric circulation. These are still large scale, they're larger than sea breezes and larger than individual pressure systems, but they're not quite as large as our Hadley cells and Ferrel cells, for example, but nonetheless they have a major impact on the weather systems of Australia and other places where their influence is felt. The first one we're going to look at is ENSO, or El Nino Southern Oscillation, and you've probably heard of El Nino. Now, El Nino, the principles behind El Nino is that the trade winds, which are developing from the high pressure cells at 30 degrees north and south, and movement of air into that intertropical convergence zone, means that the winds across the Pacific are moving in this westerly direction. They're blowing air from South America, predominantly eastwards towards Australia. Now what that does, as that air is moving over the surface of the ocean, it is dragging with it some of that water. It's piling it up further onto the western Pacific, onto the east coast of Australia. Now because the top layers of the ocean are warmer, you've probably felt that in any body of water, a lake or even swimming pool at certain times of the year, you dive in, the top layer is warmer, and then the layers beneath, which can be much colder, we call that a thermocline. Because the top layers are warmer, then that piled up water that's being pushed over by those trade winds will mean that you will get more warm water on the western Pacific, and you will therefore have space for cold water to come up on the eastern Pacific over near South America. And you can see that in this diagram here, which shows the thermocline of the ocean, of the Pacific Ocean. Now, what that does is produce a high pressure cell because of the cold air off the coast of South America, and a low pressure cell off the east coast of Australia. So you have rising air off east coast of Australia and you have falling air over South America. And again, we have that typical convection cell that we've seen at different scales throughout this part of the subject. Now, we call that a normal phase because this is what occurs 50% of the time. And that cycle is called the Walker cycle, named after the person who discovered it. Okay, so this is a normal phase, and Australia experiences its normal, and I've got normal in sort of inverted commas, is because Australia has a very variable climate, and what's normal anymore. But nonetheless, this cycle occurs in this way about 50% of the time. Now, sometimes those trade winds increase. Nobody really knows why they do, but they do. And of course, what that does is piles up even more warm water over the western Pacific, over the east coast of Australia, and intensifies that low pressure system. And so you have a greater low pressure cell, you have more air rising, it's got to go somewhere, it falls down onto that more intense high pressure cell because it's even colder, because there's more cold water coming up, and that is like another feedback loop. It continues it even more. And so you have more water, more warm water piling up over Australia, intensifying that low pressure cell. And what do you have? You have much wetter conditions in Australia. You have sometimes huge floods down the east coast and southeastern parts of Australia. And over on the coast of South America, you often have droughts occurring. The opposite of a La Nina is El Nino. And again, for some reason that system breaks down, goes through the normal, returns to the normal, and then it continues to break down, and the winds almost stop and sometimes reverse over the Pacific. And so you end up with this more complex diagram of winds moving eastward over the western part of the Pacific, and you end up with a much smaller convection cell over the eastern part of the Pacific. Now, what that means is because the winds aren't blowing the water towards Australia, that warm water sloshes back across the Pacific. And so you end up with much cooler water near Australia and much warmer water in the central part of the Pacific and closer towards South America. And so you end up shifting that rain band more towards the eastern part of the Pacific, and that's when you get much wetter conditions in South America. And for us, those low pressure cells are not as intense anymore, and so we get much drier conditions. And it's during these El Nino conditions that we have much more stable weather and sometimes extended droughts. So many of the droughts that we've had in Australia has been associated with this El Nino event. Okay, now we measure ENSO by looking at the difference in sea surface air pressure. It's between Darwin and Tahiti, just for interest. And a more negative Southern Oscillation Index means we have El Nino, and a more positive means La Nina. And you can see here how it's changed between 1991 and 2015. Or this current graph of the last 12 months shows that it's moving towards a more La Nina event. But the Bureau also produces graphs of sea surface temperature, like this one here, and you can see that it's also been heading towards a more La Nina event. Okay, so we're possibly heading for a La Nina event and hopefully a bit more rainfall. The other large-scale process I'd like to look at is the Indian Ocean Dipole. And it's a similar sort of process. This refers to the year-to-year change in sea surface temperatures in the between the western and eastern parts of the Indian Ocean. And it too has a major effect on Australia's rainfall. So it varies between neutral, negative and positive, and it has about a 3 to 5 year cycle. In neutral conditions, warm water near Indonesia creates rising air that falls near Africa and westerly winds near the equator. And we can call that a normal condition. And there's not a huge impact either way on the rainfall of Australia. In a negative phase, the westerly winds intensify. Again, nobody really knows why. More warm water moves east and Australia gets more rainfall. So a very similar mechanism to ENSO occurs with the Indian Ocean Dipole. When we get a positive in the dipole, then we get a reverse situation. So the westerly winds weaken and sometimes easterlies form and moves warm water away from Australia, creating more cold, which means more high pressure systems, more stable air, and we get a much drier conditions. Now, sometimes we can get a positive Indian Ocean dipole and we can get an El Nino. They can occur together, and if that occurs, then we get much less rainfall, particularly in the southern part of Australia. And the same thing could happen the other way around. And if we look at today's data, we can see it's in fact indicating a negative Indian Ocean dipole. And then, as we saw before, we're heading towards a La Nina. So perhaps, who knows, we'll see in a few months' time whether we get massive amounts of rainfall, because those two major influences on Australia's weather seem to be heading towards that wetter situation. All right, so that concludes our look at major systems of weather affecting Australia.